Recently, I have worked as the architect and the lead developer on a medium-sized greenfield C++ application, and I found a few big pain points of C++ that I think are worth discussing in this video. So let's start a little rant. So before we begin the discussion of the biggest pain points in C++ software development, there are a few points I'd like to clarify. So I've been a huge supporter of C++. I've read the C++ programming language book by Bjarne Stroustrup and a few other C++ books, but now I have kind of this love-hate relationship with it. So I do realize that a lot of these issues are in C++ because of historical reasons, and I highly respect C++ for being able to stay in this industry for so long, yet I still believe it's valuable to kind of discuss these things. So don't treat it as, like a hate letter to C++, but more as a discussion in this field, just stating what I don't like about it, and yeah, maybe start discussing what I can do with it. And if you have suggestions, what can be done with these big pain points, then please write it in the comments below the video. So I'm not an expert C++ developer because there are probably very few experts. And frankly, I've seen even members of the standards community make mistakes and make error, get things wrong, which is completely natural with such a complex beast as C++. But I'm also not a C++ newbie. So I've been programming in C++ for over 9 years now. And a lot of this has been done professionally. And I really always try to, stay on top of the newest state of C++ in the industry. Yet there are still a few things which I think maybe they are more and more problematic, especially if you have the experience of working in other languages. And maybe one last caveat here is that I come from the audio programming background, so it includes a mix of this standard business UI logic in C++ and also real-time high-performance programming. So this may give you maybe a little bit of a context of which side of C++ I'm approaching. So now let's go to the list of the biggest pains of C++ development. And the first one is that compiler support is lagging behind the standards on certain platforms. So I definitely admire how the standard has been developed over the last few years, starting with C++ 11, but everything we got in the subsequent standards was better and better. But a lot of compilers are still very much behind. For example, working with Apple Clang was a big pain recently because it still doesn't support C++ 23 stood expected, but it also doesn't support C++ 20 JThread, so joinable thread. I have no idea why it would be so complex to implement. And it also doesn't support std stop token, which can be used to stop thread execution, so signal thread execution. I have no idea why it's like this, and it's a big pain because if you're working on a cross-platform project, which is always the case in audio programming, then you need to use C++ 20 without certain features because it's still not possible to switch to C++ 23. Surprisingly, Microsoft is now in the lead with C++ standard implementation. They also were the first ones to include experimental modules implementation, which I think is kind of funny historically, but yeah, good for you, Microsoft. Okay, the second big pain point of C++ is still this declaration definition split. So if you're not familiar with it, like typically in C++, you write the declaration of your class or function in a header file, an implementation in an implementation file. There are exceptions to this, like header-only libraries, but that's the typical workflow of C++ application. And it's a very elegant solution, but I feel that it was good for all times. So now it doesn't seem necessary, and it lengthens development time significantly. So imagine that you have you use the pointer to implementation pattern. So you only declare a class and its functions in a header file, and you move the full implementation details to the source file. So you basically have if you want to change a signature of a function, you have 3 places you need to change it, and especially like the return value, right? So changing this 3 times is really tedious, and the tools are still not very helpful in all of the cases. They often get it wrong. So that's what I find really, really tedious. And for example, in Rust, you don't have to do it. You have one declaration definition. Maybe there are still reasons to do it, but there's a whole of C++ modules that will circumvent this, and I hope it comes soon. And speaking of which, it's basically still hard/impossible to write C++ cross-platform modules nowadays. Modules were introduced in C++ 20, but still cross-platform support is, I don't want to say it's limited, because it's probably there. So I've seen CPP talks, that CPPCon talks and other C++ conference talks exactly on this topic, and still I fail to use them in my own project. So it seems like way too complicated for a average developer. I hope this changes soon over time. Really, let's hope for the best. Okay, the next big pain point is that if you want to prevent this header source file split, what you can do, of course, you can implement everything in headers, so you have a header-only implementation. But the problem is that because headers are included transitively, if you change a header file that's used in a lot of places or is very crucial to your application, then you basically need to recompile your whole application. And if you use the Pimple idiom, that helps. But if you use templates, you need to define everything in the header files. And so this really slows down development, unfortunately. Then, another thing that's related to it, if you get something wrong, especially with templates, the compiler messages are not very helpful. So with the C++ 20 standard, the concepts were introduced which check, template, class template and function template arguments for certain preconditions. And these help a lot, so you can learn a lot from them, but they're still, not very, very helpful. I think that, I believe that Clang was supposed to initially shift all those hardships away from C++ compilers, and it definitely did so a little bit, but still often, in C++ compiler messages, the error is not shown where it actually is. So you do really need to be a good C++ programmer to understand these compiler messages. And again, I believe, for example, Rust does this perfectly. It really underlines where the error is, what's the possible cause, why it failed compiling certain code, and then it also can provide you even more explanation if you ask it for. So again, you can tell it, okay, I'm not so experienced developer to be able to understand these messages, and say, okay, but if 9 years is not sufficient to understand compiler messages, then maybe something's wrong. Another problem of C++ is that there is no standard dependency management, which means that managing other people's code that we would like to use for, code reuse to getting some functionality for free depends on third-party package managers from external ones that are not defined by the standard. And the most popular ones, for example, Conan and VC package, for me are regarded still as a little bit difficult to use. And that's partly because the documentation is not rich in examples, and they're also these third-party package managers undergo rapid development, which means there's a lot changing, and the documentation is often not up to date. And out of these, for example, like with VC package, what I found is that it's very difficult to set up, a third-party library to be used from a specific commit, right? Because it's the third-party libraries are managed in a repository, and there all these specific versions are checked in. And this is in contrary to the CP/M package manager that I found. I think the easiest one to use is the most one tightly integrated with CMake. And I think if I were starting a new project, I would use CP/M, but then it's not as fast as those other package manager. So if you'd like to know how to use, for example, the Juice C++ framework with the CP/M package manager, I have a video on it. You'll find a link in the description or somewhere alongside this frame of this video. And I highly encourage you to check it out. And that's what I would recommend for starting out. But I hope that the situation improves. Fortunately, Conan and VC Package both have vibrant communities of users who are willing to help if someone has any trouble. And another problem with third-party libraries is that there are no standard recipes to build them, right? Even if they depend on CMake, which is already a great situation to be in, the way you build them is very custom always. So these package managers, they try to simplify it, they try to abstract out this building procedure, but it still somehow influences your project. And there are various flags to be set, and they're set in different ways. So it's not often clear what happens, why, what you should change, etc. Which is a kind of a hassle, even if you're, if you're just starting out in C++. And finally, if you have a third-party library, it's hard to predict on which platforms it will run. So if you would like to support, macOS, Windows, Linux, Android, and iOS, you really need to do thorough checks to be sure that, a third-party library is supported on all of these platforms, because these libraries rarely do such guarantees because of how dynamic this whole ecosystem is. Another thing that's painful in relation to third-party libraries in C++ is that it's hard to suppress the warnings from those libraries. So let's say you want to be, very accurate, you set the highest warning level, you treat warnings as errors in the compiler, but then bam, you're using some third-party library and they don't care about compiler errors, or frankly, it's maybe sometimes difficult to stay up to date with the introduced warnings and errors. And also the standard changes, some things get deprecated, but it's often you need to build a huge workaround to suppress the warnings on all those third-party libraries. And I think the most difficult setup is that because of some header file inclusions and some library inclusions, some file that you don't have control over is being built as part of your library. And it's very hard to suppress the warnings in those files. What I found is the best way is to simply set the warnings just for your source files which you're using, but it's very difficult. Okay, switching gears a little bit, another big problem with C++ is that unchecked memory access is super easy to do. So if you're not familiar with it, memory access, out of memory access is accessing memory or attempting to access memory that does not belong to you officially. So either it can be some other process's memory and that your process will probably crash, and that's a good thing. But most often it's memory that belongs to some other part of your program, and then you're in the undefined behavior land, which means that you have no guarantees whatever will happen in your program whatsoever. And it's very, very easy. So if you're using vector, for example, and you use the subscript operator, then there are no checks performed at runtime. So even if you do out-of-memory access, you won't be notified of it. And if you come from the Java side, there you're accustomed to getting this array out-of-bounds exceptions. Well, that's not the case in C++ unless you use the specific add member, which you should probably most always do. And this may also be very confusing to people, and especially it introduces bugs that are super hard to find. And the list goes on and on. Unwanted memory leaks that also may happen quite easily, even if you're using smart pointers. Then double delete if you're managing the memory on your own. And then what's maybe problem in modern C++, use after delete or use after move. And that can always happen if you're using references to variables that have been moved. and then you attempt to use those references. This behavior is a source of weird bugs, and it's very easy to do. And basically, compiler does not warn you about this, or warns you about this very rarely. So again, here I saw that, you know, Rust's compiler does a way better job of informing us of these things. And well, I can only hope that the support for this in C++ will improve. But there's C++ is built in a way that does not make it easy for the tooling to inform us about these kind of errors. Okay, so the next thing on the big pains of C++ on our list are confusing macros. So in C++ you have a very powerful and flexible macro system, which is able to transform completely however your program is functioning. For example, what you can do, you can define a macro that's called private, and the value of this macro will be public, which means that whichever private members you have in your classes will become public in your program. And if you include this macro before any other code in your program, then you'll set up for kind of a disaster if you then try to program something further. So and this again comes completely unnoticed, and using the macros itself is very difficult, even to the point that the founder of the language, Bjarne Stroustrup, really strongly discourages the usage of macros. But of course, because they're so flexible and powerful, it's very tempting to try to use them. But again, for newcomers to this language, it's something that's quite difficult to understand. And frankly, macros are still being used in a lot of places. Another big pain of C++ that I found is poor linting often. So linter is a program that analyzes your source files and tries to build this abstract syntax tree and tries to get all the which variable references, which number, etc. And in C++, because of all these header inclusions, the source file gets extremely long, and it's very difficult for the linters to keep up. So typically, if you have a large program, your linter will refuse to cooperate. That's, for example, what happened to me on one project where I think it was C++ ReSharper. It simply said, okay, like this project is too large, I cannot help you anymore. So again, this is something that's really bothers me, because again, if for people that are just starting out, linters are typically life saviors. So if your linter does not function, well, there's very little you can do, and you basically are as good as with a plain text editor, maybe with a slight touch of syntax coloring. Okay, another big pain of C++ is when you're starting even a new project, you have around 1,000 of style guides to choose from, including the most popular ones like Google, Chromium, LVVM, and Microsoft. These are just 4 style guides of how to write your code, but of course they have their variations. You want to use vanilla styles, but you use their variations. Deciding on the code style of your project is very important at the start. Especially if you'd like to set up, formatting your source files automatically. But you really need to be explicit about this, because as soon as you're not and you start coding, then probably any other programmer will have a different style of writing C++ code. So and then your project loses consistency, and it's then very difficult to read, debug, and etc. And again, in Rust, there's a standardized style guide, and if you are not adhering to this, you'll get a nice compiler warning and linter warning that this variable should be named in this style. So again, it's a lack of good defaults simply, and that's also maybe confusing to people just starting out in C++. Speaking of lack of good defaults, in C++ there aren't any good defaults basically, or there are very little good defaults, but there's a ton of, good advice, good practices. And that makes it difficult, because you need to know this good practices. So you get loads and loads of good practices with C++. but very few good defaults. And the problem with good practices is that people often argue about them. What I found, for example, there's this concept that when you delete a variable, you should set the pointer to it to null. And then some people argue strongly for it. Other people are strongly against it. They say, okay, if you set to null after delete and it's necessary for your program to function, that it means something is wrong with your program, right? So you should keep it as it is and then handle the possible errors that come out of it. So there are these two sides of a discussion. And if you're new to C++, you're like, okay, just tell me what should I do. And another, I think, example of good practices that are not established is whether you should pass by const reference, by value, or by error value reference. So on a very basic level, it seems very easy, but if you really want to get it right, you start watching these long talks about specific types and how you should do this, and then it's really confusing, and there's still no mutual agreement as to this, also in linters. So I think for newbies it's very difficult. I think here is worth noting a small exception to lack of good defaults, because I found that C++ lambdas are extremely well designed. C++ lambdas are immutable by default. That's a huge advantage, and you have to be very explicit what you're doing. It's super clear what is happening. There are very few things happening under the hood. So I really, really admire the design of lambdas, and I think it's a great example of how the standard is able to come up with new concepts to enhance the language, and with it introduces already good defaults. Another pain, I think, of C++ is still a relatively small standard library. So in the current standard library, there is no standard networking code, unfortunately. And another example is that there is no standard JSON parsing. And you can say, okay, the C++, it's never been there, it's not designed in this way. But in other languages, it's often standardized. And in C++, you're again left with being forced to use some third-party libraries, which is a hassle on its own. If you had it in the standard, you would have a standard way of approaching this. Then I think another lack of C++ is still a relatively small number of threading utilities. And I think there's a lot more going on in this area right now with the introduction of C++20 coroutines, and also some more features related to coroutines in the standard library in C++23. And I saw there's a very nice proposal now with standard execution, with this task-based concurrency and scheduler. So I'm really looking forward to it getting accepted. I think the chances are pretty high that it will be accepted, maybe if not for C++26, then for C++29. But then again, we're left, on the in the wake of the compiler support and how fast will they come up with the implementations of these libraries. Yeah, we'll see. Fortunately, there are very good libraries that are kind of extensions of the standard library. A great example is the Boost library, which I highly recommend to use. But again, Boost can be quite complex at times to understand. And another great library, of course, is the Juice C++ framework, which introduces a lot of utility classes that really simplify the life of C++ development and have very easy to use, kind of Java-like APIs. And I think not using these libraries, not leveraging their power hinders a lot of people in working on C++ projects. Another example where C++ only now gets up to date is handling UTF-8 characters and strings. So library support emerges just now for this, and it's been several years behind where other more modern programming languages are already using the UTF-8 model. So string handling in C++ is another thing that's very complex, although it should be very simple. And I I still personally, I don't understand it fully myself. So I think that a lot of newcomers will have similar problems, especially if they need to translate between UTF-8 strings and, you know, other encodings. So I'm hope that maybe one day we can, you know, settle on a single standard and use it simply. But I also saw that although the standard has the utilities in place, not all compilers support them, right? So yeah, I just hope it will get better over time. But right now I don't envy anyone who's really needs to work with strings in C++. Plus there are a lot of string functions lacking, I think, that are very, you know, easy utilities that you have to write on your own because the standard does not support them. So another kind of big pains to C++ is that there isn't a standard way of writing multi-threaded code, of structuring it. And that comes together with another point on my list, is that the coroutines are quite complex to understand and use. So introduction of coroutines is kind of a double-edged sword. It allows you to write clearer code, but at the same time introduces a whole lot of complexity that you need to understand, and a lot of caveats that you need to be aware of. And I'm looking forward to being able to get more and more quality coroutine materials, and personally looking into some coroutine libraries that introduce more utilities. But yeah, we'll see how it develops with a standard execution proposal. Maybe we'll have an opportunity for a standardized structuring of multi-threaded code. But until now, we're on our own, and we need to deal also with the third-party libraries that help us in this task. And the final thing about C++, what I found is that a C++ community can be difficult at times. I don't know if I was unlucky, but it seems that whenever you mention raw pointers, like everyone starts screaming and saying you shouldn't be using raw pointers, you should be just using smart pointers, disregarding the fact that if you're working with C APIs or with low-level programming, you often need to deal with raw pointers. So I have this feeling that a lot of people in the C++ community are very advanced, are like super experts in C++. So if you don't know something, then, you know, you're a dummy and you shouldn't be asking about this. Maybe that's my wrong impression. Maybe I had bad luck. But I found other communities much more welcoming to newcomers and to even, frankly, stupid questions, right? Because if you understand something, that seems easy to you, but if you don't understand something, that seems hard to you, and that will always be the case. So even I think stupid questions should always be encouraged. But yeah, I'm curious, what is your impression of the C++ community? And I guess that people who go to CPBCon may have a completely different opinion on this. Finally, I wanted to mention that C++ is not all bad, right? I still like it and I still like working in it. This video was a way of discussing some of the problems that I have with C++. But let's at the end mention a few positive sides. So one of the things I love about C++ is that you are in control 100% of the time. So you know when a variable is destroyed, you know where a thing on the heap is also destroyed if you're using smart pointers. You decide when something will be allocated. You decide where something will be deallocated. You know exactly what happens under the hood, right? It's not some hidden machinery. It's all specified in the standard how it should work. And if something is not specified that you cannot rely on it, then you should avoid it. And I really, really love this aspect of C++, that you can use exactly every opportunity your machine exposes directly from your code. Not to mention that you can always easily integrate C code and even assembly code into your program. So you're in control all the time, and but this extra flexibility often costs you bugs in your program. So it's up to you. What do you prefer? But this aspect of C++ is definitely enticing. What I also love about C++ is that the standard is evolving at a rapid pace. It's moving into a wonderful direction. I love all the additions to C++ 11, 14, 17, 20, 23. and looking forward to the new standards. I'm super excited what will be there. Unfortunately, as I said, this is hindered by compiler support. Well, I'm talking about you, Apple Clang. But yeah, I'm super excited what the future of C++ will bring. Then, what about, I said I was talking a lot about C++ quirks, but you don't have to know it all, right? You just need a small subset of C++ to get going in this language. And I think Bjarne Strustrup, a tour of the C++ language, which is something like a very small 5-chapter book, is a great place to start. So that's maybe encouraging that you don't need to know the whole standard before you can jump into C++. If you're interested in what you need to learn from C++ to start writing audio code, I've listed it all in my audio developer checklist, which you can get for free at thewolfsound.com/checklist. So it lists every bit and piece of knowledge that I believe is necessary to become a full-fledged audio developer, and in particular it has a section on C++, which I believe may be of high value to anyone who would like to start in this area. Another positive thing, as mentioned, is that there are third-party libraries who make your C++ life a lot easier, like Boost and Juice Framework. And as I believe is one of the reasons why still Rust has not taken over C++ completely, because Rust still lacks such powerful libraries and such powerful support from frameworks as C++ has. So that's another huge benefit, that thanks to this long history of C++, we have these great third-party libraries and frameworks. Maybe also I think Qt is worth mentioning here. So that's a huge, huge benefit on its own. Let's pause here for a moment. One tool that significantly simplifies the life of C++ developers, especially those involved in audio programming, is Juice. Juice is an open-source, cross-platform C++ application development framework that makes it easy to create audio software, as well as audio plugins and plugin hosts. You can write code once and build VST, AU, AUV3, AX, and LV2 plugins on Windows, macOS, iOS, Android, and Linux, as well as embedded platforms. I've been successfully using Juice since 2018, both in my private and professional projects, so I'm delighted that they're sponsoring the video. I especially like how Juice makes it easy for beginners to jump right into creating audio plugins and applications without worrying about C++ quirks. Juice is used by the majority of the world's most important audio companies, but it is free for personal use, and there is affordable pricing available for companies just starting out. Apart from the framework itself, Juice has an amazing community of users gathered in the Juice forum, which is a great resource to learn audio programming on its own. Most recently, the Juice team released the preview branch of Juice version 8, which contains many new features, including WebView plugin UIs, which is very exciting. To start using Juice now, go to juice.com, download Juice, and follow their Getting Started guide. I have also put the link to it in the description. Have fun creating audio apps and plugins. And now, back to the video. And then I think in C++ it's worth mentioning there are very beautiful projects with C++ code, and one of them that I really like to recommend to reading is called Serenity OS. So it's the most complex type of software that you can write, an operating system, and it's written fully in C++ and it's beautiful C++. It's clean C++. So if you would like to see what in my opinion is best practices in action, that I highly encourage you to check out Serenity OS. I'm not sponsored by them. I'm not endorsed by them in any means. I just believe this project is amazing and everyone should check it out and just read the source code for the pure enjoyment of looking at nice C++ code. I have put a link to it in the description below as well. So in summary, in this video, I described all my biggest pains of C++ development. I feel so much better now being able to throw them off my chest. And it was not supposed to be a rant. This was supposed to be a kind of discussion. And I'm curious to see if you agree. So have you found these points also difficult? And if yes, please describe what your struggles are, maybe how you overcame them. And if you think these problems are easily solvable, please also mention this in the comments as well. I'm learning all the time. Also, I'm learning C++ all the time. So it'd be awesome to learn something new out of this video. So if you liked the video, please hit the thumbs up. Subscribe for more C++ discussion videos and tutorial videos, and turn on notifications in order not to miss them. And just a small reminder, if you would like to become an audio developer and write C++ audio code, then check out what's necessary, in my opinion, to learn to do so in my free audio developer checklist at thewolfsound.com/checklist. Once again, thank you for your attention, and I'll see you in the next one. Take care.